SBQ1 Term 2 for Grade 11 Advanced. So the graph shows the force and displacement of an object that is being pushed. I need to figure out the work done. So from this graph, I can see that the work is the area, and I can find the area by finding half base times height, which will give me half 45 by 3, which is 38 joules. Now, what is the work done by gravity if a ball weighing 45 Newton, so the force of gravity is downward as it falls. So basically, the two vectors are in the same direction, so it's not a negative work. So it is F by D, and here sine of the angle is 0 in the same direction. 45 by 1.5, it will give me 67.5. What is the net work required to accelerate 1000 car from 20 to 30 meters per second? I apply the work kinetic energy, which is the difference in the kinetic energy. So it is half 1000 by the velocity final squared minus half 1000 by 20 squared. It will give me 250 thousandths. A car traveling at a constant velocity covers a distance of 100 meters in 5 seconds. The thrust of an engine is 1.4 kilonewton. I need to find the work, so basically, the power. So the power is the work divided by the time, and the work is force by distance over time, which is 1.4 by 100 divided by 5 seconds, and it is 28 kilowatt, because the force is in kilonewton. Now a bead is moving at a speed of 20 meters per second at position A. So VA is 20, and the height of A is like 200 meters. I need to find the speed of the bead at the point C. Giving the height here 160, I don't know the velocity there. I apply the conservation of mechanical energy here due only to the kinetic and the gravitational potential energy, and the same thing there at position C and at position A. Now eventually I can cancel out the mass because I have it everywhere. I am left with half 20 squared plus 10 times 200 equals to half VC squared plus 10 times 160. So VC is 34 meters per second. Now a ball moves across a surface from point A to point D. I need where it has the maximum gravitational potential energy. So GPE is actually only due to MGH. So at the maximum height here, I have the maximum gravitational potential energy. At maximum H, I have maximum GPE. Now the next page, from the graph, I need to know the maximum gravitational potential energy. As I can see here, the gravitational potential energy is 80 joules. Based on this, I need to calculate the mass of the brick. Knowing that the height is 8, so GPE is mgh. So replacing GPE by 80, the mass I don't know, G is 10, and the height is 8, I can find that the mass is 1 kilogram. Now also from the graph, I need to know the kinetic energy of it at 1 second. So here is the graph of the kinetic energy. At 1 second, I can see that the kinetic energy is 50 joules. Based on this, I need to calculate the speed of the brick at 1 second. So given the kinetic energy equals 250, which is equal to half mv squared. 50 equals to 1 over 2. The mass is 1, v squared. So v equals to 10 meters per second. Now the following question, I have a spring constant 400 Newton per meter. So that is K. Alright, and is attached to one end to a wedge fixed rigidly with a horizontal part. A 40-gram mass, here I don't like the 40, I will convert it to kilograms, so I'll divide it by 1000, so it's 0.04, is released from rest while situated at a height of 5 meters on the curved track. I need to calculate the maximum compression in the spring. So let me call them again, situation A and situation B. Applying the conservation of mechanical energy, the kinetic energy at position A plus the gravitational potential energy at position A and the elastic energy at position also A should be equal to the sum of the kinetic at position B plus the gravitational at position B and the elastic at position also B. Now, because the object started from rest, this means that the velocity here equals to 0. Actually, also on A, I had no compression when the object was on position A, the spring was not compressed. That is because x of A was equal to 0. Later, when the spring will be compressed at position B, the block will stop. So that's because VB equals to 0 and position B is on the ground, h of B is equal also to 0. I will be left with mg h of A equals to half kx of B squared, which is the one that is in question. Now let me replace everything by its value. So the mass is So the mass is equal to 0.04 times 10. The height is 5 equals to half. K, I have it 400. Now xb squared. So 0.04 by 10 by 5. The answer is x of B equals to 0.1 meters. Finally, the last two questions. I have a bike of mass m equals to 30 kilograms and moving at 25 meters per second. I need to find the kinetic energy, half mv squared. 1 over 2 by 30 by 25 squared. It will give me 9,375 joules. The last question, a spring is compressed at a distance x equals to 0.04 4 meters. When the energy stored in the spring, so I am given EH, the energy of the hook. What is the spring constant K? So I need K. Given the elastic energy equals to half kx squared, I can replace each by its value. Half k is unknown, so 0.04 squared. When I put it in the calculator, I will have k equals to 250, and the unit is Newton per meter. Solving the last question, which is the bonus, I need for which ramp will the speed of the ball be the greatest? Eventually, they will all have the same speed because initially they all have the same GPE at the same height. So basically they will all have the same kinetic energy, yani the same velocity. So the speeds of all the balls will be the same for all the ramps.